As you know, during weeks 2, 4, and 6, you are assigned an extra assignment known as the iLab. In your course, the instructions indicate that you are to use Excel, but as we've discussed, you also have the option to use Minitab. Now, since the instructions within the course are speaking about Excel, the professor who does the iConnect lecture focuses his examples using Excel. So I am going to do a demonstration pretty much similar to what that instructor does, only I'm going to do the demonstration using Minitab so that those of you who opt to use Minitab will have a demonstration showing you how to do the iLab using Minitab. Those of you who want to use Excel can follow the demonstration that is posted in class and that's already there, and those of you who want to use Minitab can follow my demonstration. Either one is fine. The labs are the same, the problems are the same, the data is the same. The only thing that's different is the form of technology that you elect to use. So if you are using Excel, you will just use the week 2 lab document that you see here under week 2 iLab. If you are going to use Minitab, you should go up here under Doc Sharing. I have posted a different template, and the only difference is the steps are written using Minitab terminology so that you're guided using the steps for Minitab. So I've posted the week 2, 4, and 6 template already. So you would click on Minitab week 2 lab doc. Additionally, you would get the data from here as well for either lab, no matter which kind you're going to do, whether you're going to use Excel or Minitab. If you're using Minitab, you're going to use this data set that's .mpg. You would use .xlsx if you're doing Excel. So for our purposes, we will do mpj. I think I didn't say mpj a minute ago. But anyway, here is your template that you'll use. So I'm going to open this one up. So I'm going to click on it and I'm going to say open with, and it'll just open with Word automatically. Now, I am going to be using a completely different data set for this demonstration because I'm not going to do your lab for you. I'm just going to do a demonstration lab. You are going to have to do your own lab, but this one will be pretty much identical. I will just be using different data than you have. So when you go to do your lab, you will need to download the data from here on this page in Doc Sharing. You'll need to grab your template also if you are using Minitab. The template looks a little different in that the steps outlined on the template and the instructions for running the procedures are written for Minitab because they're a little bit different than Excel because the commands are different. So you'll want the template for Minitab if you're using Minitab. So you have two options here with your data downloads. If you have Minitab on your computer and aren't using Citrix, it may be easier just to go ahead and download the data in Minitab form because you'll be able to open it right up on your computer. And the way you would have Minitab already on your computer is if you went to that website that I had given in my demo video in Media Gallery and had downloaded it for the trial version for the 6 months. If you're not sure what I'm referencing, go back to Media Gallery and take a look at the demo on opening and accessing Minitab. I showed how PC users could get a copy of Minitab on their computer for 6 months. If you don't have Minitab on your computer and you're using DeVry's copy in Citrix, that's fine too. It may be easier for you just to go ahead and download the Excel copy of the data and then just copy and paste it into Minitab. It's a little easier, less complicated to get that data in there, and then from there you're just straight on Minitab with everything. So if you're going to download and save, you're just going to click on it. and you're just going to save that file. So I would just save it somewhere where you can find it again. Save it to your desktop if you want to. You know, just wherever, someplace where you can pick it back up and open it again. Okay. So that's how you're going to get that done. And then what you're going to do is go over here to iLab. Of course, after you've gotten your template, you want to get that template and save it. Now remember, when you save that, you want to save it with your last name and your first name. Don't forget to do that. So you're going to go, like I would go Dodson, if I could spell my last name, Beth. And then you've got the name of the course. And save that also somewhere where you can find it again, okay? Then you're going to go to iLab, and we're going to go to, whenever it loads, we're going to go to the Citrix environment. And I was already logged in. It may take you a moment more if you weren't already logged in. And we're going to click on Minitab. I'm going to get that to open up. And there it is. It may take yours a bit longer to open. Mine was already open, so it just kind of popped right open for me. But sometimes it takes, like, you know, maybe even like 20 seconds or so. So don't panic if it's not opening up right away. All right. Now, to copy that data out of Excel, you would just open that Excel data sheet. So it looks pretty much like this. It looks really a lot like a Minitab data sheet. They both just look the same, really. And then you just want to copy that data. You just want to make sure you get it all. So what I like to do is start with that arrow right there and just come all the way down and make sure you've got all the way down to all of it. If you've got that arrow, you can see that it's got everything. And then right click and copy. Let it get all that data. Still spinning. Okay, it's got it, and then I just move that out of my way. And then I just click right here in this first cell. Make sure you're up in that gray part and paste the cells. And you see how I got everything. And I always just scroll down and check. And I compare that I'm down here in 35 is my last row, and I look at my Excel and I look to see that I've got the last data set, or the last thing in that row is the number 6 OR. I just compare the two things. 6 OR, 6 compares to OR, and the last thing in the bottom right hand side should be a 1, and the bottom right hand side over here is also well, this one's a 6. Let's see what I missed, or if I was even looking in the right place. Yes, I was. I was actually looking in the wrong column there. I was looking in the right place here. So I should have 1, 4, 6, and then 1, 4, 6. So yes, I got everything. All right, so that's good. Now we're good to go. You've got your data saved in here. So you can go ahead and start on your iLab. So what we're going to do is, here is your template. You've got all of your instructions here. Down at the bottom, you can see this is the code sheet. These are the questions that were asked to collect all of this data. And so what this means, the variable name drive, if you look at your data set and you find where it says drive miles, here's what happens. It's telling us that this is how many miles each one of the people that answered the question, this is how many miles they drove to get to wherever they were questioned about. So the question says, how long does it take to drive to school on average to the nearest minute? So each person answered, and these were the answers to the nearest minute. This question was, what state do you live in? What's your shoe size and your height? These questions that you're seeing are not questions that you need to answer. These are questions that were answered in order to give you this data set. So let's see how to complete the lab. The first question asks you to complete a graph. You are to complete a pie chart. So let's create a pie chart for the variable car. So that means the question that was asked about cars. They were asked for the variable car. It was question number 10. What color of car do you drive? And that data is right here in C 10, no, it's not in 10. Where is car? Car color is C7-T. Car color is right here. They're either gray, black, gold, orange, dark gray, white. I see green. Now remember, this is not the data that you are going to have. It is just similar to the data that you are going to have. So the first thing we do is we go to graph, pie chart, and click in the category variables box so that the list of variables will show up on the left. So the instructions are right there for you. All you need to do is follow them. So we're going to go to graph, and then let's just make this so we can see everything all at once. We're going to go to graph, pull up pie chart. Let's find pie chart, and click in the categories variable box so that we see everything we have here. And we are interested in the car variable, so we're going to double click on that so it shows up over here where we want it. We're going to include titles by clicking on labels, and we want to type your name in the title. So I'm going to type in Beth Dodson, and in this same labels window, select the tab slice labels and click on all. There we go, and we want to click on all of these, and if we want to, we can draw a line from the label to the slice. And there we go. We can click OK, and we can click OK again, and there we've created a pie chart. Now we want to copy and paste it into our answer template. So we can right click to copy the graph, and then we're going to come over here and we're going to paste it into the gray box, and there it is. Now it's in your box there, and you can format it a little bit so you can read it, or you can keep it small like that. And I'm going to backspace a little bit just to save some room. You don't have to do that, but your pie chart is done. So let's go on down to do the histogram. The histogram says create a histogram, and you can just close this out over here on your Minitab sheet. Create a histogram for the variable height and choose simple. Then set the graph variable to height and include a title by clicking on labels and type it into the correct text area. Put your name in as the title and click OK. Alright, so we're going to pull up graph again. We're going to click on histogram, and we are going to choose simple, which is already chosen. We're going to set the graph variable to height. So the graph variable is going to be height. So we have two choices here. We can either double click right here, or we can click it once and hit select. So you choose, but however you like to do it. Include a title by clicking on the labels button. And we're going to put our name in as the title. Also going to put height. How's that? And we're going to put our name in, and we're going to click OK. And click OK again. And then we're going to copy. And we're going to paste. And that one is done. So now we're being asked to create a stem and leaf plot. Create a stem and leaf chart for the money variable. Now the money variable was asking how much money they were carrying in their pocket at that time. So let's go back to graph, stem and leaf. Let's find the money variable and put it into the graph box. And we want to set the variables to money, enter 10 for the increment, and click on OK. The leaves of the stem and leaf plot will be the ones digits, and of the money variable. So note that the first column of the stem and leaf plot that you create is the count. The row with the count in parentheses includes the median. The counts below the median accumulate from the bottom of the plot. So then copy and paste the graph here. So here is your stem and leaf display for the money variable. So what does this show us about how much money the students were carrying in their pockets? Well, it shows us that the majority of students have money in the range between what, $18 to back down to, I don't know, below $20, I would say. Probably that's where most of the students had less than $20, because this is where the majority of data seemed to fall, was below $20. There weren't as many above 20 as there were down there below. So that's kind of how you could interpret that. So calculate the descriptive statistics for the variable height by gender. We're going to see how students vary based on their height, based on whether they're male or female. So we're going to calculate descriptive statistics. We are going to go back into Minitab. We're going to pull up Stat, Basic Statistics, and we're going to display descriptive statistics. So we're going to set variables to height, and we're going to choose height by a specific variable. So we're going to select by variable, and we're going to enter gender because we want to know height based on male versus female. We're going to click OK. And we're going to look for male versus female, and we're interested in the mean and the standard deviation. So the mean for the females is 68.9, and the mean for the male is 70.4. The standard deviation for the female is 2.845. And for the male is 3.269. So now you want to interpret what we are seeing in the work that you've done. So what is the most common color of car for students who participated in this survey? Explain how you arrived at your answer. What we can do here is go back to our pie chart and see which one occurred the most often. Now remember, it may not be just one. If we look at this pie chart and we look at the percentages that we see, it's really difficult to see in my picture here. So if you saved your pie chart over here, you can probably go back and look at it a little more easily in Minitab. If not, regenerate it. It was quick enough to do. But I can kind of see if I look closely that white and black have an equal percentage of 25.7. They both have 9. I don't see that any others are a tie or more. So I would say white and black occur the most often. So I would say white and black are the most common. We arrived at that answer because they both have the same largest percentage in the pie graph. And then you could go on and tell what that percentage was. All right, so then it's asking, what is seen in the histogram created for the heights of students in this class? Include the shape. All right, so if we look at this histogram, we can kind of see where the majority of students lie. We can see where the tallest height is. So the tallest height here is at 72 inches. The majority of students are falling right in the 70 to 72 inch height, and we can also see that there's a skew here. there's a pull to the left, which gives us a negative skew. So this is negatively skewed, and the majority of heights are falling in the 70 to 72 inch height range. So this is a left skewed graph. With most heights falling in the 70 to 72 inch range. And then what is seen in the stem and leaf plot for the money variable? Include the shape. Well, we already said that it looks like most students are carrying less than $20. And if we were going to include the shape, we could turn that on its side if we turned that 90 degrees. And I would call that a right skew. It would look like the tail was falling to the right. So this would be right skewed. And then we're going to compare our means. Let's compare the mean height for the males and the mean height of the females in this data. So the height of the males is going to be, as we said, the mean height for males was 70.4. So for males, the average was 70.4. For females, we said the mean was 68.9. So it looks like on average, the males are taller by approximately 1.5 inches. And that's just on average. We're going to say that males are taller by approximately 1.5 inches. So then we want to compare the standard deviations. So the standard deviations, if you recall from our discussion board, tells us how consistent data is, or tells us how much variation there is in the data, how much movement there is, or how many big changes there are. So the females, or let's start with the males again like we did in the average. So the males have a standard deviation of let's just call it 2.7. And the females have a standard deviation of 2.85. So what that tells us is that the males have a larger standard deviation, which tells us that male heights have more variation amongst their height, which makes sense because you tend to see males with a larger a greater variation of height. You tend to see a larger disparity among heights in males usually. You see like extremes in male heights, whereas with women, women are generally, when you have a large group of females, they're all pretty close in height. There's not large extremes. However, if you had a large group of men, you would see some extremes, or more often you would see extremes. All right, using the empirical rule, 95% of female heights should be between what two values? Show work or explain how your answer was calculated. All right, so recall using the 95% rule. Remember we talked about how we knew where 68%, 95%, and 99.7% of the data should lie based on 1, 2, and 3 standard deviations from the mean. So really, to do this calculation, all we need is the mean and the standard deviation, when we need to know whether 95% is 1, 2, or 3 standard deviations from the mean. So 68% holds 1 standard deviation, 95% holds 2 standard deviations, and 99.7% holds 3 standard deviations. So if 95% holds 2 standard deviations, for female heights, then if we have the mean in the middle and we're going to go out 2 standard deviations on each side to get 95% of the data, then what we're going to do is we're going to take the mean for the females, which is 68.7, and we're going to have plus or minus 2 standard deviations, which a standard deviation for the females is 2.85, in order to get 95% of the data. So we're going to have 68.7 minus 2 times 2.85. Okay, sorry, 68.7 minus 5.7 is going to give us 63, and 68.7 plus, it's hard for me to type as quickly as I talk, 5.7 is going to give us the other end of that range, which is 74.4. So we would expect that 95% of the data would fall between 63 and 74.4. So there we go. So we would expect 95% of the data to fall between 63 and 74.4. There we go. All right, so we do the same procedure for, did I say 68%? 95% of the data. I think I said 95%. All right, so we would expect 95% of the data to fall between 63 and 74.4. All right, so the same procedure for 68%, only the change that's going to occur would be, instead of 2 standard deviations, we're only going to do 1 standard deviation, so there would be no multiplication. You wouldn't do 2 times 2.85 or anything. You would just do a single standard deviation on either side of the mean. So you're going to do 68.7 plus or minus a single standard deviation, which is essentially 1 times 2.85, so 2.85. So then you're going to have 68.7 minus 2.85 is going to give us 65.85. So there's your lower end of your range. And then you're going to have 68.7 plus 2.85. So there's your upper end of the range, and that would be 71.55. So there is your range for 68%. We expect 68% of the data to fall between 65.5 or 85 and 71.55. Okay, and so then you would just save your template and submit your work. Now, I've given very brief, quickly typed answers. I would hope that you would maybe expand on those answers just a bit, show a little bit more understanding, and not just copy verbiage word for word. And remember, I'm using different data, so please don't just copy these same answers. You have different answers, different numbers. So you need to pay close attention to what you're being asked and how you're answering it. But the process is exactly the same. So good luck with your week 2 lab, and we'll do this again in week 4.